We'll be talking about the weather outlook for this year and even for the next 10 or 12 years, because I think that's important to every one of us. So if you have any questions, yell question and stick your hand up. If you yell loud enough, I'll hear you. Remember, you're yelling at a great-grandfather. So we'll pay attention to that. To be ahead of the game, the markets today are a little different than they were yesterday, with the December corn contract at $4, 1.5 cents. Still, we would anticipate that while you're harvesting, we may see the December contract at $5.50. So that's things to keep in mind. That isn't my number. That comes from someone who knew what he was talking about. The soybeans, they're kind of hidden in there. They're, of course, doing all right as well at 10.13. And by the time we get to harvest, that is the number that we're seeing there. We expect the contract to stay about the same on that. When I say we, I mean the guy who does that work. Here you see this morning's picture of the world, showing where the clouds are, what the temperature is at the various places. That is, the desert is orange and kind of yellowish where it isn't that hot. But I'm looking at the little circles to see where what is going on with the clouds. Look at the one at the right first. It is the northern edge of Australia with no storminess going on there. The Australians have been noticing that. They're a bit dry in that country, and they're going to stay dry for a while until we get into a La Nina, which gives them moisture. And once things dry on the other side of the ocean, look at the left-hand side of the picture now, and the lower ellipse going along the equator, and a few clouds in it, indicating that there's a chance of an El Nino coming into place in the next 2 months. An El Nino is good for Midwest farming if you like large yields of corn and soybean. If you're buying feed, you probably like that. Those clouds that are forming in there indicate that the El Nino may be forming when the cloud bank gets a little more dense and reaches the west coast of South America. Looking at the other ellipse that's up higher, not very much going on in the Pacific, except there are still a couple of large storms that go all the way from Hawaii to southern Alaska, moving across. And a little circle that is in the Midwest, which circles the storms that we had yesterday. Still moisture moving up from the Gulf of Mexico, and when disturbances come, there's moisture that can fall in this area. It has just been moving, much to the frustration of people in Illinois, along the Ohio River after it comes up from the Gulf of Mexico, where our moisture comes from. This is a little closer look at the possibility of an El Nino. The bottom short picture that you're seeing shows what the ocean looks like when there is an El Nino event going on. The red, very warm clouds and ocean temperatures are in the area. When there is an El Nino, that brings rain to Ecuador, Peru, Colombia, and that's how it got its name, because it's usually strongest around Christmas time, so they named it the little boy, meaning the Christ child, the El Nino. The idea of a La Nina being the opposite is of more modern origin, just meaning the opposite of an El Nino. Possibility of El Nino, increase in crop yields is a possible thing when that occurs. Here you see the pictures. Red is the El Nino. It occurs about every 7 years, except in the middle of the picture where there's a lot more red. I've got it behind a little bit of a faint green there. And you see more red than blue. And the red is a dominance of the El Nino going on, giving us moderate risk for crop production in the Corn Belt. Moderate risk means that drought is rare. Below trend can occur. Above trend is a 70% chance when there is an El Nino going on. The La Nina was more dominant in the left-hand third of this picture, where you see mostly blue icicles hanging down, or La Nina, and in those years we had few El Nino events compared to after 1976 up to 2006. We are going back into that situation where the adverse La Nina is likely to be more common than the favorable for large crops El Nino event. The El Nino, as I mentioned, is the friend of the Midwest farmer if big yields are what you consider friendly. It's a better friend of the Argentine farmer. El Nino tends to be a Christmas event, as I mentioned earlier, that may or may not persist all of the way into the Midwest summer, but usually it does. So if they have one in South America, it usually persists for close to a year once it gets started, meaning that if they have an El Nino, we probably will. This is the trend since 1987 of corn for grain in the United States. The thing I want you to notice about it is the left-hand 1/3 of the graphic. The left-hand 1/3 has more ups and downs, more volatility from year to year of grain production than the next third of the picture, or next fourth of the picture, when you see very consistent yields, very close to the trend line. And then after that, we have one slight diminishing and a whole run of years above trend. 1, 2, 3, 4, 5, 6, 7. 7 years is enough to get people suspicious. 7 years of above trend yield in a row is a rare happening. Right after that, we did have a strong La Nina and the first drought since 1988, almost to the extreme left of this picture. A drought is defined by law in this nation. We can thank Congress for that. They got tired of not knowing whether it was a drought or not and everyone arguing about it, and so they passed a law. It's a drought if the yield of a crop is 10% below the trend, or more. After we went through that period of 7 years of above trend line yield, then to a strong La Nina. Also, that introduced a period that we expect more La Nina events. We anticipate that drought will be more common as we move ahead during the next few years. Maybe the worst drought of the century will be around 2025. Why did I say that? Because the worst drought of this past century was 1936. The worst drought of the century before that was 1847, and so forth back for 600 years, looking at tree rings for the previous ones to indicate when there was a drought. The droughts tend to be 89 years apart, the major droughts. It has to do, we think, with the cycle of the sun and its activity. That's where our weather comes from ultimately anyway, is the strength of the sun's energy on the earth, and it goes through an 89-year cycle known as the Gleisberg cycle. If you can spell a German name, you can look up Gleisberg when you go to your computer and just Google Gleisberg. If you want to know how it affects yield, put Elwynn Taylor after it, and you'll see what I've had to say about that. During the summer of 2017 was a slightly dry year for corn, and people were amazed at how high the yield came out. The reason was it was not hot. When we can get by with a lot less water if the temperature's not hot. How much less? If the temperature goes up, let's say the temperature every day for a week at the time of corn is tasseling here in Iowa, the temperature every week happens to go, every day of the week happens to go up to 74 degrees. Your crop will use 1 inch of water out of your soil that week. If the temperature every day went up to 84, you use 2 inches of water. 10-degree temperature increase doubles the amount of water a crop uses. If the temperature goes up to 94 every day of that week, the crop will need 4 inches of water if it can get it. Usually, they can only draw water at that rate for 2 or 3 days, even if it's there. Then it catches up, and the plants end up with the leaves curling if it's corn, or looking at the bottom of the leaflets in a gray-looking field if you're looking at soybean. The summer of 2017, slightly dry in the Corn Belt, but it was not hot, and that's why 17 had the successful yield that surprised a lot of people. Talking about the extremes of the La Nina, the purple line you see represents the undulations of the jet stream when there's a La Nina going on. It gives us very changeable weather, very extreme, because of the great ups and downs, if you want to look at it that way, of the major jet stream that controls our weather. If an El Nino is going on, it's more consistent, and is, for us, brings us closer to a normal year. Our crops do best under normal weather. The deviation from normal is greatest during La Nina years, both hotter and colder, wetter and drier. All of the variations are greater during a La Nina because of the wandering, you might say, of the jet stream. Going from a small yield to a large yield as an example, between 2010 and 11, and looking at the little risk wheels that I put over to the right, where the yellow meets the blue is an average crop if it's right at the bottom of the circle. If yellow meets blue at the bottom of the circle, it's most likely to have an average crop, like the middle one that you see there. Green is a record high yield. And where yellow meets green is 10% above the normal yield. Where yellow meets blue is the trend line yield. Where blue meets red is the 10% below a trend, or the red area is a drought area. You can see if you look at this that when there's an El Nino, the red area is small. We have had droughts during an El Nino, but they're rare. We often have them during a La Nina. In fact, there becomes a 30% chance, as expressed on the risk wheels. Just as an example of how changeable things are, going from 2009 to 10, we went from an El Nino, look how the blue is from the Gulf of Mexico to Canada through the Midwest. Plenty of moisture. To a La Nina, hot and dry, and the drought of 2012. You can also look at Arizona. That in the bottom picture is purple, and in the top picture is dry. So the top picture at El Nino is a drought, often for Arizona, and a flood when the El Nino is going on. We get a drought in the Midwest and a flood in the Arizona area. You'll also notice in these pictures it appears that it's doing exactly the opposite thing between Arizona and Montana. Almost always that's the case. If weather's favorable for crops in Montana, it's unfavorable in Arizona, and vice versa. In fact, there are great forests in Arizona. Sometimes they have forest fires, especially when the El Nino's going on. Almost never during the La Nina, because they're sopping wet in Arizona. We have the drought then. in this part of the country. We are expected to return to an El Nino sometime this summer by some scientists. The ones that have the best track record, by the way, so I pay attention to them. Then remember, the El Nino is favorable for yield. This is a historical graph I've put up for 2015, when we had a 70% chance of being either in the yellow or the green, that is an above trend line yield. We pay attention to those things. The soybean yield follows along nearly like the corn yield, but it's not as consistent. It is harder to forecast a soybean yield than it is a corn yield. I think it's because soybean plants are smarter than I am and finally figured corn out as the years have gone by. In 2015, another historical chart of a 70% chance of an above trend line yield, but still in the soybeans we had a yield that brought us, because it was so far above the trend, right in the middle of the yellow, $9.80 beans, as opposed to the $10 that you expect if you have the normal yield. So you can adjust your risk of prices by the risk wheel if that's the kind of thing you pay attention to. Climate risk in agriculture is likely to be greater this next 20 years than it was in the past 20 years. That includes the Corn Belt, that includes Florida, that includes all of the agricultural areas of the United States and South America as well. Management of risk becomes increasingly important in these more volatile times of yield. This is winter. The harsher the winter, the further down those points come. If you look at the left-hand third of the chart, you see that we had rough winters when I was a kid. I don't know how many times I told my children, quit complaining about the winter. You should have seen them when I was a kid. Oh, Dad, I said, look at this. I've got data. You haven't had a harsh winter worth talking about. And see that, see where way over to the right now, we see we had a harsh winter a couple of years ago. I heard one of my granddaughters saying to my son, look, Dad, we're having winters like Grandpa had. You got off easy. And yes, we do go through a cycle. And we'll be about 30 years in rougher winters than we've had this past 40 years. Why? It has to do with where the Gulf Stream goes when it leaves the Gulf of Mexico. Where does that warm stream of water go when it leaves the Gulf of Mexico? It can hug the coast of the U.S., or it can head directly for Portugal. And that gives us opposite winter effects. And then if it's right on Portugal, it'll start to work its way back, and it'll take it about 35 or 40 years to make it. And that's why we have this type of a variation in our harshness of winters. The corn yield, again pointing out from back around 1925 up to 2012, in this case it says 11 on the chart, but the last blue mark on the chart is the yield for 12. The thing I want you to notice, first the dashed black line. That is what the Iowa corn yield will be if the weather's as good as it ever gets for corn. And you can see on the very highest yields that we've had, about 5 of them on the picture, we touched that dashed line. If we have the very best weather we could have for corn, in this next year we'll be up there over 200 bushels for Iowa yield quite easily. Also, you will see in here, in the middle of the graph, ups and downs, the extremes. 25 years of very volatile conditions, ups and downs, and also around from late 20s into the 50s, the lower left portion of the graph. That is the same volatility both places in percent deviation from year to year. And inside of that chart, around over 1960, and inside over the year 2000, 18 years of consistent yields. This pattern has gone on for over 1,000 years, not of corn, but of plants growing, particularly trees that leave a record here in and near the Midwest. 25 years of very volatile conditions. The 2012, the low yield that is the last one I've on this chart, the first year of 25 years of greater volatility. More importance should be paid to managing the risk in your marketing and in the other activities that you have that are important to your success as a farmer. Or if you're just a consumer of grain that is feeding animals, still a greater volatility in the prices. Learn to manage that risk of the more ups and downs that we're seeing in the middle. The people in Chicago make their living by volatility. So do you, but not necessarily on purpose. But my mom always said, I'd like the price, I'd like to know what the farm's going to produce, I would like to know what it's going to be worth. Well, I guess that was a good thing, but if you want to make a profit, you need to have it going up and down. When the price is high, sell things. When it's low, buy them. I learned that from my 4th grade teacher. Not a bad thing to keep in mind. We are coming into the 25-year period of greater volatility, more opportunity to make money, but it will also look a lot like the 1980s, when there was a lot of opportunity to make money and a lot of opportunity to go bankrupt. And many of us in farming learned a whole lot about trying not to go bankrupt, but make money during that period of time. Use what you learned this time. It's the 25 years of high volatility. A little bit on, is a weather pattern going to persist for a long time? You say it's been wet around here for a month. Well, the next month may be dry. The next month may be wet again. When do these things last a long time, like 3 months? When the change is on the continental divide. I've drawn a blue line between the orange and the blue on this chart. That blue, almost vertical line is close to the continental divide. And the nation was divided between a much below average and a much above average condition that divided on the continental divide and persisted for 7 months. When you see the division is there, plan on it staying. If the division was between Illinois and Indiana, plan on it being gone next week, kind of thing. So look for the things that persist if you wish. The U.S. Drought Monitor comes out every week and gives us a good idea of what is under stress in the country. However, it's a much misinterpreted chart, the Drought Monitor, because the yellows do not cause drought. They tell you to be ready for it, to be watching the trend. When you get into the oranges and the red are the drought conditions that will take the crop yield to 10% below trend. The yellow hues just take away your chance of having a record high yield per acre. And the reds give you a possibility, increasing possibility of having more than 10% below the average or trend line yield. So those are the things we pay attention to. Here is the current Drought Monitor, just came out this morning, and you see a little bit of the yellow edge in South Iowa, a little bit in Illinois. This is taking away the possibility of a record high for that part of the state. And you see that it's most of the drought is down in the Four Corners area, Utah, Colorado, New Mexico, Arizona, and normally a dry area except up in the mountains. Now, it doesn't cause a great deal of difference except to forest fires. People have asked me about hurricanes. We've had the first two tropical storms that could have been hurricanes, ended up just as storms, one going on right now off of the west coast of Mexico, not likely to go to California, and one that came ashore in the Gulf of Mexico, brought a band of rain all the way up into Canada, going almost directly north. We are not getting more hurricanes now than we used to. The hurricanes coming ashore in the U.S. are the dark blue at the bottom. It has its ups and down years, but there's no trend of increase. And people say, with climate change, are we getting more hurricanes? The answer to that is no. It seems to be controlled by something else. The top part of the graph, the lighter blue, are the number of hurricanes that were out in the ocean and didn't come ashore. And only the right-hand quarter of the picture is really accurate on that. On the left, because you don't know one that didn't come ashore when we didn't have satellites to pick them out. Now we know them quite well, rather than just having a ship happen to have run into one. The Corn Belt has shifted due to the shifting precipitation pattern. Here's how the Corn Belt has shifted. And over to the right of the picture, the bottom right, you see where the center of the Corn Belt was, down near St. Louis, Illinois, Missouri area, back in 1950. Every 3 years, it's been replotted where the center of the Corn Belt is. The last one is the top left dot. Around Iowa City is now the center of the Corn Belt, where East St. Louis was the center of the Corn Belt as recently as 1950. This is what our shifting climate has done. It has moved the Corn Belt because suddenly Minnesota, eastern Nebraska, and eastern South Dakota became major players. Just bringing back to your mind for the last time, look at this chart. The high periods of variability, we are entering one now. It's the opportunity to benefit from volatility. Yes, they benefit from volatility minute to minute, second to second, day to day in Chicago. It's hard to compete with them. They're no good at year to year. A farmer can do better. Thank you for inviting me to be with you. I wish you a good year.